Okay. Today I want to talk about the section C, the 2.1, the derivative and rate of change. So this is outline. I'm going to talk about definition of the derivative of f at a, slope of the tangent line, velocity and rate of change, problems. The first one. The Wasilek definition of the derivative of f at a. The derivative of f at a is this one. Limit f of x minus f of a over x minus a as x approaches a. So we have another one here. The another formula is you can choose like this one. The a is fixed point. You choose x value. So as like this length, so we can write this is h. So we have this h is x minus a. So we can replace limit denominator x minus a is here h. One more. So we can replace x by h. How can you replace? We can use this equation. You add a to the both sides. This is same to the like this. A is cancelled. X equals a plus h. You plug this value into here. X. So we have f of a plus h minus f of a. The next one, you can replace x approach a by using h value. So what does it mean? X value approach a. What's that? X is here, 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 here. What happens? H value approach to 0. The length is going to 0. So we have h approaches to 0. So this is ideal for deriving another limit definition. So we have two definitions. So we use notation f prime of a or dy over dx at x equals a. This is like f prime of a, the derivative of f at a. I'm going to give one example. You can calculate f prime of 2 of f of x. F of x equals x squared negative 3x minus 1. So here, how can you calculate? So we use this rule. We can only plug 2 into a. 2 here, 2 here, or 2 here, 2 here, 2 here. It doesn't matter. You can use either one. Either one. In this case, I'm going to use second one. But depending on your choice, you can use your first one, second one, it doesn't matter. We have same answer. So this is the same to like this. So what's that? This is same to limit. H approach to 0. You plug 2 plus h into x. You plug into this x. So we have 2 plus h squared minus 3 times 2 plus h. Minus 1 is exactly f of 2 plus h. Minus f of 2. What's f of 2? You plug 2 into x. You plug 2 into x. Here, 2 into x. So we have 2 squared minus 3 times 2 plus 1 over h. Like this. The next is to simplify. Limit h approach to 0. Was it like 2 plus h squared? I can calculate. 2 plus h squared is the 2 plus h times 2 plus h. I want to use for rule. The 2 times 2 is 4 here. 2 times h times 2 is 2h plus 2h, 4h. Last one, h times h. h times h is h squared. So this first one is here. 4 plus 4h plus h squared. The next is distribute -3. Distribute -3. -3 times 2 is -6. -3 times h is -3h. Keep -1. Next, distribute -1. Here, here, and here. The 2 squared equals 4. The 4 times -1 is -4. Second one, -3 times 2 is -6. Times -1 is +6. This 1 times -1 is -1 over h. The next, use just only cancelled common thing. 4 is cancelled. 6 is cancelled. 1 is cancelled. What's the remaining things? Limit h approach 0 here. The 4h minus 3h is only h plus last one h squared over h. Next, fact out h. The numerator has common factor h. Fact out h, h times 1 plus h over h. So what's that? Here, h is crossed out. This is a limit. H approaches 0, 1 plus h. The last one, you plug 0 into h, we have 1 plus 0 equals 1. We have it. This is like a whole idea for solving this problem. Like this. That's good. The next problem. Was it like a tangent? So I can explain the tangent. But here we have graph. Graph is like this. This is x-axis, y-axis. We have graph of y equals f of x is given. I can choose one point. Here, this point is like P. So A and f of A. So what's that? Here, x component A, y component f of A. So this point is P. I can choose Q. So here, one more. What's like tangent line? Tangent line is like this. Only touch at one point. So exactly this line and line, like this. This is tangent line. This is like a tangent line at one point. So we call this is tangent line. Tangent line, so we call. The one more. So we can denote slope of the tangent. We can write m. Oops, this is m. Like this. So m. So one more. I can choose point Q. This point Q is like x and f of x. What's that? Here, corresponding x component is x, corresponding y component is exactly the f of x. So like this. I can connect this point P and point Q. We can connect these 2 points. So we have this line. This line, like this, that we call secant line. This is secant line. We call the secant line. The next one. Was it like a slope secant line? The slope of the secant line is, this is secant line is, I can use rise over run. How can you find rise over run? You can make a right triangle. So like this. So the rise is this length. This length is rise. So exactly the f of x minus f of a over. What's run here? This length. A to x. X minus a. This is x minus a. So I can denote this one by MPQ. Just notation. So like this. The slope of secant line. But next tip. I just only move point Q to point P. What happens? The Q is moved to P along the curve, move here. So secant line is like this. This is secant line. The move more. This is Q. This is secant line. Like this. So move more approach P. So what happens? This is secant line approach to tangent line. So we have this result. The secant line approach to tangent line. So like this. So I can replace this one by this statement. The Q approach P, so like this. What happens? Corresponding x value is here. Corresponding x value is here. Corresponding x value is here. What does it mean? X value approaches A. So Q approach P, automatically x value approaches A. So exactly the slope of secant line, slope of secant line approach to slope of tangent line. Like this. So this is equivalent to x value approaches A. The slope of secant line is here. F of x minus f of a over x minus a. Here, f of x minus f of a over x minus a. Approach to slope of tangent line is notation M. This is whole idea. So I can change this one to mathematical notation. So what happens? F of x minus f of a over x minus a approach to M. What does it mean? The mathematical notation is approach. It's like limit. Approach to M as x value approaches A. You can change. So what's that? This is same to f prime of A. This is like a whole idea of finding slope of a tangent line. What's like a slope of tangent line? The slope of tangent line is the derivative of f at A. This is slope of the tangent line. This is like the second result in section 2.1, like this. Yep, so like this. That's good. This is like a second result. The next, we just only solve one more problem. Find an equation of a tangent line to the hyperbola y equals 3 over x at the point 3, 1. So how can you find equation of the tangent line? Do you know this one? Here. So we have the basic stuff is here. Graph is given. Choose one point. This is like A, f of A is given. I can draw tangent line. What's the equation of a tangent line? I want to use Poincare form. So we have y minus f of A equals the slope of tangent line is f prime of A times x minus A. That's it. I can use this equation. So here, from this example, what is A? What is A? Could you write your answer on the chatting board, please? So what is A? What do you think? What is A? So do you know A in this problem? So do you know A? So, okay, no problem. It's good. It's good. Don't worry. Don't worry. So the A is here. What is point P? This point P is X component A, Y component F of A. You can compare. Point is, this one is a given point. So what's that? This 3 is A. This 1 is F of A. This is like a given point. X component is A. Y component is F of A. So we have F minus Y minus F of A is here. Y component 1. You can calculate F prime of A is 3. X minus 3. This is like exact equation. How can you find F prime of 3? So we use this one. F prime of 3 is, you can use limit definition. Limit H value approaches 0. We can use for, this is like definition. F of 3 plus H minus F of 3 over H. This is idea. So what's like F of X? F of X is given function here. So we have F of X is 3 of X. This one. What is F of 3 plus H? You plug 3 plus H into X. So we can keep limit H approaches 0. We have 3 over 3 plus H minus, what's F over 3? You plug 3 into X again, 3, sorry, over 3 over H. So this is same to limit. H approaches 0. First one, 3 over 3 plus H minus, crossed out, just 1 over 1 over H. So one more. I'm going to make a common denominator of 2 fraction. What is the common denominator of 3 over 3 plus H and 1 over 1? So what is common denominator? Do you know common denominator in this problem? What's the common denominator? Do you know? Who? What's like common? Yeah, 3 plus H. You're right. Thanks. So you can change second one. 3 plus h over 3 plus h. Multiply like this. So we have limit h approaches 0. Only calculate numerator. 3 is a numerator. Distribute the -1 to the first and second one. The -3, negative h over common denominator 3 plus h over h equals limit h approaches 0. 3 is crossed out, just minus h over 3 plus h. I don't change this to the multiplication. The denominator is like h. This is times reciprocal of h is 1 over h. H crossed out. So we have limit h approaches 0, negative 1 over 3 plus h. The next step, you plug 0 into here h. So we have -1, 3 plus 0. We have negative 1/3. That's good. So you plug this value into here. So what is equation? Y minus 1 equals -1/3 x minus 3. So that's it. This is the answer. So I want to simplify this one to the like intercept, slope and intercept form. So distribute -1/3 to the first and the second one. This is the same to y minus 1 equals negative 1/3 x. -1/3 times -3 is positive 1. You just only add 1 to both sides. So we have y equals negative 1/3 x plus 2. That's it. This is exact equation of tangent line. Equation of tangent line. This is the whole idea for solving this kind of problem. Okay. So far so good. So do you have any questions so far? It's good. So what do you think? It's good? Yep, good. So if you have any question, don't worry. Always write your question on the chatting board. I will answer your question. So don't worry about it. Yep. So here, the same to my lecture, like this. The next one. So we think about velocity. So here, suppose an object moves along a straight line according to an equation of motion S equals f of t, where S is the displacement. Displacement is directed distance of the object from the origin at time t. F is called the position function of the object. What is average velocity over the time interval a to a plus h? So I use displacement over time. Displacement is distance, like the distance of time. So how can do that? So we can use this one. Here, we have time interval a to a plus h. So here, time t equals a. So this object in here, this is time t here. This is a time t is increasing from a to a plus h. Here, time t equals a plus h. Time t equals a plus h. Object is here. So move to the like this. So what's like this position? This position is f of a. This position is f of a plus h. So what's that? Here, displacement over time. Displacement is distance between the two objects, exactly f of a plus h minus f of a. This is like distance over. Time is The later time is a plus h. Previous one is like a. The time interval is a plus h minus left one. So we have f of a plus h minus f of a over h. This is exactly average velocity over the time interval a and a plus h. So we have the like this. The next tip. H approaches zero. H is going to zero. What does it mean? This is like a time interval here. This is a plus h. H approaches zero automatically. A plus h approaches to a. So what happens? The average velocity approaches to instantaneous velocity at time t equals a. We use notation VA. This is velocity at A, just notation. So what's that? So this one is, what's VA here? VA is like this, because what's like a VA? The average velocity is here. So I can write here, the f of A plus h minus f of a over a. Sorry, h. Sorry, it's h. Average velocity approach to instantaneous velocity. Notation is VA as h approaches zero. What's that? Exactly same to f prime of a. What's that? Derivative. How can you find the instantaneous velocity? What velocity? Just use f prime of a. Exactly derivative of f at a. This is velocity. The velocity. This is idea. Like this. To give one more example, suppose that a ball is dropped from the upper observation deck of the CN Tower, 450 meters above the ground. The equation of motion is S equals 4.9 t squared. The first question, what is the velocity of the ball after 5 seconds? Second one, how fast is the ball traveling when it hits the ground? So we have two questions. How can you solve this problem? The first one, was it like a velocity? The v of t is the next one. The limit f of t plus h minus f of t over h, h approach 0. We can use formula. This was like f of t, this one, 4.9 t squared. This is the equation of motion is exactly f of t. F of t. So how can you do that? It's the same to limit. H approaches 0. You plug t plus h into t. You can keep 4.9 times t plus h squared minus the f of t is exactly 4.9 t squared. 4.9 t squared over h. The next two, calculate limit h approaches 0. Was it 4.9 t plus h squared? Here, t plus h squared is the t plus h times t plus h. You can use for rule. The first one, t times t squared. Outer, t times h is th. Inner, h times t is th. Outer plus inner, the th plus th is 2 times th. Last h and h. H times h is h squared. So we have 4.9 t squared plus 2th plus h squared minus 4.9 t squared over h. And calculate more. So what's that? It's the same to limit. H approaches 0. You can distribute 4.9 to first one, the 4.9 t squared. Second one, the 4.9 times 2 is 9.8. So we have plus 9.8 th. Last one, 4.9 times h squared is plus 4.9 h squared. Last one, negative 4.9 t squared. Negative 4.9 t squared over h. So what happens? 4.9 t squared is crossed out, cancelled. So we have limit. H approaches 0, 9.8 t times h plus 4.9 h squared over h. The next two, we have a common factor h. The h is a common factor. Factor out h, limit h approaches 0. Factor out h, 9.8 t plus 4.9 h over h. H is crossed out. So we have limit h approaches 0. Remaining part is 9.8 t plus 4.9 h. The last step, you plug 0 into h. 9.0 times 4.9 times 0 is 0. It's going to 0. Remaining thing is 9.8 t. That's it. So we have this velocity. The velocity is 9.8 t. This is the idea. You can use this rule. We have it. So what's the problem? What is the velocity at 5? Do you know how can you calculate velocity after 5 seconds? How can you find? By using velocity. How can you find the velocity after 5 seconds? Do you know how can you calculate velocity after 5 seconds? It's good. You're right. Thanks. 9.8 times 5. You plug this 5 into t. You're right. Yeah, thank you. So we have the v over 5 equals 9.8 times 5. 9.8 times 5 is exactly 49. Was it like unit? This is like use meters. You can use second, 49 meter per second. That's it. This is 3 of 5. 3 of 5. It's good. This is the idea. Like this. The second problem. How fast? This is like a typo. Sorry. How fast? Sorry. How fast is the ball traveling when it hits the ground? How fast is the ball traveling when it hits the ground? What does it mean? You can find velocity of the ball when the ball hits the ground. So how can you do that? So here, first, you can calculate this one. This is like CN tower is given, CN tower. This is like ground. Was it like distance between top of the CN tower and the ground? Exactly 450 meters. What happened? Ball is here, ball is down. So like this, ball hit the ground. What's the distance? 450 meters. ball hits the ground, the total traveling distance is 450 meters. So first, you solve the distance S equals 450. What is S? S is 4.9 t squared. You plug into here. 4.9 t squared equals 450. Next, divide by 4.9. So we have it. Next, take square root. T equals, so we have two answers, like even power, square root of 450 over 4.9 or negative square root of 450 over 4.9. So which one is T? First one, second one. Positive one, negative one. Which one is T? Positive one, negative one. Yeah, positive one, because time is always positive. You have to ignore negative one. So we have it. The approximate value is 9.6 seconds. The next, you can plug this time t into velocity. So we have velocity of the ball as it hits the ground is v over square root of 450 over 4.9. You plug this number into here. 9.8 times square root of 450 over 4.9. The approximately equal to 94 meters per second. This is like idea. But don't worry about your quiz, your exam. So we don't give like a complex number, don't worry. So we can give like a simple number. So you can calculate by your hands. Don't worry about it. Don't worry about it. The next one, the rate of change. Here, suppose y is a quantity that depends on another quantity x. Thus, y is a function of x, and we write y equals f of x. We can define delta x, x2 minus x1, increment of x. Delta y is f of x2 minus f of x1, increment of y. So we can define the average rate of change of y with respect to x over the interval x1, x2, exactly delta y over delta x. So delta y is here, x2 minus x1. Delta x is, delta y is here, f of x2 minus f of x1, you subtract. Delta x is here, x2 minus x1. We have this result. So similar, x2 approaches x1, what happens? Average rate of change approach to instantaneous rate of change of y with respect to x at x equals x1. So what's that? You can change. What's the average rate of change? Here. This one. Exactly. F of x2 minus f of x1 over f of x1. Oops. I can erase a little bit here. F of x1, x2 minus x1 is average rate of change. Approach, what does it mean? This is mathematical notation. Approach to instantaneous rate of change. I can write like R, I can write R here as x2 approaches x1. So what's that? This is exact definition of f prime of x1. So how can you find instantaneous rate of change of y with respect to x at x equals x1? F prime of x1, exactly derivative. The derivative is rate of change. This is the idea. like this. So we have it. Okay, I wanna summarize. What is f of x2 minus f of x1 over x2 minus x1? So from my previous lectures, we have three important terminologies. First one, the slope of a secant line PQ. P is x1, f of x1, Q, x2, f of x2, right? Exactly, slope of the secant line. Does it make sense? Point is, given is like this, you choose P, choose Q. What's it like a P? The x1, f of x1, you can draw secant line. You can make a triangle. The rise is f of x2 minus f of x1. The run is x2 minus x1. Exactly slope of the secant line. So another one, the average velocity of the time interval x1, x2. The previous one, the average rate of change of y with respect to x over x1, x2. One more. What's the derivative of f at a? The limit of f of x minus f of a over x minus a as x approaches a. Or limit f of a plus h minus f of a over h as h approaches 0. So this is notation. F prime of a or dy over dx at x equals a. So this is same to the slope of the tangent line to y equals f of x at the point PA f of a. This is like exact meaning of derivative of f. One more, the velocity at t equals a. We can write v of a. The v of a is exactly f prime of a. The last one, the rate of change of y with respect to x at x equals a. This is three kinds of terminologies. Okay, so this is all for today's lecture. So do you have any question? The prime is slope of tangent line. Yeah, you're correct. F prime of a is exactly slope of the tangent line. Is correct. Yeah, F prime of a. Yep, you're right. So do you have any question? So if you have any question, you can write your question on the chatting board. If you don't have your question, so you can leave this like the live session. You're welcome.